we are going to identify the solutions to this polynomial equation. So how do we do that? With me, please write this down on your board if you're in class. We're going to start by identifying the factors of the constant. So the factors of 1 would just be 1. Now what differs from less than 4 to less than 5 is next we need to identify the factors of the leading coefficient. The factors of 6 would be 1, 6, 2, and 3. Now we're going to list down the possible roots. These are the possible solutions. So everything I write down is not necessarily a solution to this polynomial equation, but these are the possibilities. We first start in the numerator by always listing the possibilities of the factors of the constant, so plus and minus 1. In the denominator, it's always going to be the factors of the leading coefficient. 1, 2, 3, and 6. Okay, now I'm going to list these possibilities. So numerator divided by denominator. 1 over 1, it could be 1 or negative 1. It could be 1/2 or negative 1/2. It could be 1/3 or negative 1/3. And it could be 1/6 or negative 1/6. At this point, we are only working with real roots. I know that I'm going to have 3 roots. Now, they could be duplicated. In fact, I could even have a triple answer, like a 1, 1, 1. But I know that the 3 answers will come from this list. So if I receive an answer that's anything other than this list, I have made a mistake. Let's get started with using synthetic division, also known as the MAMA method in this class. Why I like using the board is it allows me to do it a little bit quicker, and I can erase part of the work and not have to erase the entire thing. Now, why do a lot of students probably make a mistake here? We have degree 3, and so I'm going to list degree 3, 2, 1, and 0. And now I'm going to go back and put the coefficients in front. 6, 7, there is no x to the first, 0, and negative 1. I'm looking to see which one of these possible roots will have a remainder of 0. If I don't get 0, it's a bust and it does not work. So I'm going to start by testing 1. Let's put a 1 out front. As a reminder, MAMA method is just an acronym that tells me the steps necessary to do synthetic division. I drop down the first number, everything I multiply goes back to this. 1 times 6 is 6, adding down to get 13. 1 times 13 is 13, adding down to get 13. 1 times 13 is 13, I don't have to go any further. I know negative 1 and 13 is not 0. I cross out 1. Again, this is just an extension of your previous learning in lesson number 4. Next, I'm going to try negative 1. I always try the integers first. Okay, dropping down 6. I'm multiplying to get negative 6, adding down to get 1. Multiplying to get negative 1, adding down to get negative 1. Multiplying to get 1, adding down to get 0. This tells me that negative 1 is a solution to this polynomial equation. Now, when I only have 3 terms left, and it's not always going to be that way, when I only have 3 terms left, I can go ahead, I will write this as a quadratic equation. So, no x's, 1x, and 2 x's. Now, how can I solve this? One of 2 ways. Using the quadratic formula would be one method. That always works. And sometimes factoring works as well. Now, I always prefer to use factoring. It's quicker for myself, but you can use, if you prefer, you can use the quadratic formula. Okay, let's see if this is factorable. 6 times negative 1 is negative 6, and the middle term, or the b term, is 1. What multiplies to equal negative 6 and combines to give us 1 would be negative 3 and 2. Here is where a common mistake is made. Students do all this beautiful mathematical work, and then they tell me the answer is 3 and negative 2. Remember, whenever the leading coefficient is anything other than positive 1, we have to drop that underneath. So 3 over 6 reduces to 1 over 2. 2 over 6 reduces to 1 over 3. In this form, it makes it very easy for us to identify the remaining 2 solutions. X equals 1/2 and x equals negative 1/3. I come back up here. Yes, 1/2 was there, and negative 1/3 was right here. So the 3 solutions I have would be negative 1, positive 1/2, and negative 1/3. If you went back to the original equation and you plugged in negative 1 for x and you did the math on the left, it equals 0. It would be the same thing for 1/2 or negative 1/3. If we graph this on a Cartesian plane, an xy axis, this is where the x-intercepts would fall. Let's look at example number 2. Okay, our goal is to solve this. Sometimes we can do that by factoring, and that may be the case here, but since we're working on understanding how to apply synthetic division, we're going to use that method. Factors of 1 would be 1, factors of 16 would be 1 and 16, 2 and 8, and 4 and 4, but I only need to list the 4 once. Now I'm going to list all the possible solutions or possible roots. We always take the factors of the constant over the factors of the leading coefficient. So as I list them here, you're going to see that the majority of these will be fractions. So I have 1 and negative 1, 1/2 and negative 1/2, 1/4 and negative 1/4, 1/8 and negative 1/8, and 1/16 and negative 1/16. Now, when I dive into using synthetic division as a tool to solve, I'm always going to first test the integers. I'm going to make it easier on myself. So let's make this upside down division box. This is degree 3, so I have 3, 2, 1, and 0. And I'm looking to see what has a remainder of 0. All right, let's put in now the coefficients, 16, 4, negative 4, and negative 1. I'm going to start by testing 1. Let me put this off to the side really quick so you have a little better view. I'm going to start by testing 1. Here we go. Testing 1. I always drop down the first number. This is just a continuation of lesson 4 now. And we're going to mama method. Multiply, add down. Multiply, add down. Multiply, add down. That does not equal 0. I'm going to erase it, and I'm going to go up top, and I'm going to cross out 1. 1 will not be a solution. Let's try negative 1. Let's try negative 1. Okay, here we go. Dropping down. Multiply to get negative 16. Add down to get negative 12. Multiply to get 12. Add down to get 8. Multiply to get negative 8. This does not add up to 0. If it doesn't add up to 0, it's a bust. It does not work. Now, a great question is, Ms. Bradley, how do I know which fraction to check next? It doesn't matter, but I will tell you I think like 1/2, negative 1/2 is easiest. I'm going to teach you how my mind works when working with fractions. So we're going to slow this down. If you haven't already done so, please have a 1/2 out front. Okay, when I'm ready to start here, I'm going to take this and I'm going to multiply it by the numerator and then divide by the denominator. Please watch. 16 times 1 is 16. 16 divided by 2 is 8. Add down. 12 times 1 is 12. 12 divided by 2 is 6. Add down. 2 times 1 is 2. 2 divided by 2 is 1. And when we add down, we get 0. Can I have a thumbs up or a thumbs down if you understood the process there? Okay. What do I know right now? Turn to your partner. I know one thing. Turn to your partner. What do I know? 1/2 is a solution. Okay. Now, I want you to think smarter. Hopefully, after doing lesson 4, you recognize that when you have 3 terms, we can easily solve this. Just watch right now. Don't do anything yet. No x's, 1x, and 2x. Now, before I start that whole process, if you look at 16, 12, and 2, and yes, you could use the quadratic formula or maybe factor, I noticed that all of these are divisible by 2. So let's factor out a 2. 8x squared, please do this with me, plus 6x plus 1. This is the part that I'm going to try to factor and solve with. Or if you like to use the quadratic formula, this is what you can use. So as I use the factoring method to see if it works, 1 times 8 is 8. I'm looking for 2 values that multiply to equal 8 and combine to give you 6. That would be 4 and 2. So I have x plus 4 and x plus 2, and this is where the common mistake is made. Students go, okay, the solution is negative 4, negative 2, but they forget right here this leading coefficient is not a positive one, and so I have to drop an 8 right here. When I reduce this down, I end up with a 1/2 inside, and I end up with a 1/4. Now, how is that going to help me in deciding my solutions? Well, let me bring this back here again. Opposite of positive 1/2 is negative 1/2. Opposite of positive 1/4 is negative 1/4. I have 3 solutions for this polynomial equation. Here they are. I could take any one of these, and when I substituted in for x, I did the math, it would equal 0. Or if I graphed this, I'd find the x-intercepts at these locations. The last example in this video. And so again, I'm going down with what are the factors. Factors right now of my last value is 1. That's a constant. Factors of 10 would be 1, 10, 2, and 5. All right, so let's list the possible rational roots. On top will always be the factors of the numerator will come from the constant, and the factors in the denominator will come from the leading coefficient. So I'm going to list those at this time. 1/2, so it could be 1 or negative 1. It could be 1/2 or negative 1/2. It could be 1/5 or negative 1/5. It could be 1/10 or negative 1/10. Now remember, you could touch these possible rational roots more than one time. So it may be like 1, 1, 1, right? 3 times in a row. It's not limited to only using them one time. So I'm definitely going to start by testing the integers first. That's going to be my first job. So we have x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. And I'm going to start by testing 1. All right, so I'm going to drop down. I'm going to multiply and add, multiply and add, multiply and add, multiply and add. Thumbs up, thumbs down if that made sense. Okay, now here's the misconception. Yes, 1 works, but it doesn't mean that it only works one time. Did everybody hear that? If 1 had been a bust, we didn't get a remainder of 0, and we crossed it out, it means it would never work. But when you circle it, it could happen more than one time. So now the remaining portion I have, because I have more than 3 terms, I can't solve using the quadratic formula. I can't solve with that basic factoring. So what I'm going to do is I'm going to make this again. 10, negative 3, negative 6, negative 1. Now what am I going to use to test? This exact same list. Does everybody see this? So I'm going to go back and I'm going to try 1, negative 1. Okay, here we go. Trying 1, drop down. So multiply to get 10, add down to get 7. Multiply to get 7, add down to get 1. Multiply to get 1, and it worked. So I know at this point I have 4 solutions. I know that I have 2 solutions. I have a duplicate solution at 1. So it's 1 and 1. Once I'm down to only 3 remaining, then it makes life easy. This is no x's. Let me move this down. This is no x's. This is 1x, and this is 2x's. Bless you. Turn to your partner. What 2 methods do I have to solve this? There's 2 methods. Factoring sometimes, and what else? Quadratic formula. Quadratic formula always works. Factoring sometimes works. Let's check this out. 1 times 10 is 10. So I'm asking myself, do I know 2 values that multiply to give me 10 and combine to give me 7? 5 and 2. So x plus 5 and x plus 2. Moving this down so everybody can see. We can't stop there. The answer is not negative 5 and negative 2 because remember, I have to put a 10 underneath. So when I reduce this, I end up with 1/2. Well, opposite of positive 1/2 is negative 1/2. When this reduces, we have 1/5. Opposite of positive 1/5 is negative 1/5. So I have 4 solutions, 1, 1, negative 1/2, and negative 1/5.